Hi, secondary one. Our lesson today will talk about the equation of motion. Equations of motion has two phases, one in the horizontal phase and the other one in the vertical phase. Starting by the horizontal one, firstly, we are knowing that the acceleration is v final minus v initial over time by cross multiplication. So v final minus v initial will be equating with an acceleration by the time. So v final will be equal to v initial plus acceleration by the time. This is the first equation of motion. It used when no displacement exists in the problem or not required or not given. Second equation, starting by the v average, it will be equate with v finals plus v initial over 2, or equal to the total displacement over total time. And we know that the total displacement equal to the v average by the time. By simulating the v average by v final plus v initial over 2, multiply the time to get the displacement again, and substitute the v final by v initial plus acceleration by the time. So the displacement will equate with v initial plus acceleration by the time plus v initial over 2 by the time. So displacement will equate v initial plus v initial to v initial plus acceleration by the time over 2 by time. And the displacement again with substituting 2v initial over 2 and the acceleration by the time over 2, cancelling 2 with 2, so the displacement will be equate with v initial by the time plus half acceleration by t squaring. So that's second equation of motion. Third equation of motion, starting by the v average, v final plus v initial over 2, and from the law of acceleration, v final minus v initial over time, we will get time will equate with v final minus v initial over acceleration by substituting the two equations in the law of the displacement, which equal to v average by the time. So the displacement will equal to v final plus v initial over 2 by v final minus v initial over acceleration. By substituting this law, we will get endly at the end to acceleration by the distance. Displacement will equate to the v final square minus v initial square as the third equation of motion. You have to know that the equations of motion in the horizontal phase will having a graphical representation. So the first equation will have a graph between velocity and the time, and start from the origin if the v initial or the starting velocity is 0, but it will start from the value on the y-axis. If v initial will not equal by 0, we have known that the slope is the coefficient of the x-axis, and here in this graph the x-axis is time, so the coefficient of the x-axis is acceleration. This equation is used when displacement not given or not required. By substituting the second equation of motion, d equal v initial by the time plus half at square, the graph is between displacement and the square of the time. It will start from the origin all over the relations. The slope is coefficient of the x-axis, which is square of the time, so the slope will equal to having acceleration. It used when v final or the final velocity not given or not required. The third equation is v final square minus v initial square will equal to 2 by the acceleration by the displacement. The graphical representation will be between v final square and displacement. It starts from the origin if v initial equal to 0, and start from value if v initial starting from value. So on the y-axis it will be v initial square, as on the y-axis v is squared. Slope is the coefficient of the x-axis, and here the x-axis is d, so the coefficient is 2 by the acceleration. This equation is used when no time given and no time required, or time not given or not required. The second phase from the equation of motion is vertical. They are the same equations, but by replacing the acceleration by the gravity. Here in the vertical, we have to know that the change of the velocity is require knowing the gravity. Gravity is the rate of a change of velocity in the vertical position. Replacing the acceleration in the three equation, so we have to know that the vertical motion vertical motion is dividing into three parts: free fall or projection downward or projection upward. In the free fall and the projection downward, the gravity is positive. The gravity is positive. The gravity is positive, which is mean that the velocity increase uniformly by 10 meter per second for each second, as the gravity is 10 meter per second square as a constant value. Here in the free fall acceleration, you have to know that the three equation of motion will replacing the acceleration by the gravity, and it will start always from the initial velocity of 0. At the free fall, it will be fall freely without any projection on the object. While in the projection downward, it will start always by a value. V initial will be always a value, and also gravity is positive. By substituting the slope, so it will be the coefficient of x-axis. Here in the horizontal, the slope is a, then half a, then 2a. Here also the slope is gravity, half gravity, and 2 gravity. Projection upward, you have to make a simulation for a pole or an object is projecting upward in this position, projecting upward, and then the same object will be free fall or fall again after projection. When you project an object upward, you have to know its velocity will decrease until its v final or final velocity will be equal 0, and then starting increasing again, then it reaches the same value it started from. So you have to know in projection v initial will equate with the v final in the free fall, and in projection v final will equate with v initial in the free fall. The v initial and the v final, v initial in the projection, v final will equate to each other, while the v initial and the v final in the vice versa will equate also together. You have to know that the gravity is negative in projection upward, and the slope is the same but by the negative. In the free fall or projection downward, slope is g, half g, 2g. Here the same equation, but by replacing the positive sign with a negative sign, so the slope is negative g, negative half g, and negative 2g, and also in the equations the negative will substitute the positive when substituting by the gravity. You have to know that the projection will be in the vertical, and the equation of motion, you have two phases, the vertical and the horizontal. I hope you get all the info in this audio. Thank you.